Okay, this one is actually probably going to be pretty fast. I'm not going to go over everything. I'm already losing my voice. I've only made one video tonight. There's a couple other things I got to do. So, for now, we're just going to quickly run through a couple of things and call it good. That being said, there's a couple of things that I want to look at. When it comes to a command-based program, things can get a little complicated quickly if you're not familiar with how to modularize code. So there's a lot of code here that you're more than welcome to look through. We're only going to see a few things. We're going to look at another subsystem example. We're going to look at OI. We're going to look at robot map one more time. And then we're going to look at just a couple of simple commands that I created to do a couple of different things. We may also look at a command group if I feel like it, and I feel like explaining it. But this is sort of an emulation of BP's original command-based code. So if we take a look at robot map, just to get a general idea of what's going on, we've got all of our motor controller PWM connections, encoder information. This is for a limit switch, just to know whether or not the kicker has come all the way back around. There was a problem on BP where if the kicker wasn't in a particular position, it didn't kick the frisbees correctly, and that could cause it to get stuck. So this was added to make sure that we knew exactly where the kicker was when it came back around, and it also made it so that if we could get it to work, it would auto-fire. I can't remember if we ever got that to work or not. Distance per pulse for the encoders, encoder PID and tolerance values, and gyro PID and tolerance values. These were a couple of things that BP didn't actually have, but I added them in just as an example. And then, of course, the driver USB. OI.Java looks quite a bit different. If you look, there's a lot more stuff in here. Specifically, these joystick button things. So in command base, you define a joystick button in order to perform an action. Now, I did have to create something called an enumeration. In its simplest sense, an enumeration is just a way to give a value a specific number. Normally, it would be in order from like 0 to however many items you had. In this case, I changed the order with a cheap trick. Normally you wouldn't do this, but I needed a way to define the buttons on an Xbox controller and map them to particular values. Specifically, the values that they show up as to the robot, so that way I could use them with joystick button. Because at the time there was no Xbox button class. I'm hoping that they'll add one for 2019. But you can see in OI that we create our Xbox controller and then we start creating all these joystick buttons. So, like for example, when we want to run the shooter forward, we call while active. We hand in the Xbox controller and then we get the value of button.ka, i.e. the A button. And then while the A button is held down, while it is active, we will create a new command called set shooter speed, and we'll set that speed to 1. Likewise, if we push the left bumper button up in the corner, we'll set the shooter speed to reverse. That way we can move frisbees back and forth just in case something gets stuck. We also have something like when released, which will only trigger when a button is released. That way you don't end up starting a command and then starting a command and then starting a command over and over and over again, which is what while active would do. And there are some other methods you can use for this. But basically, joystick buttons are ways that you can bind a button to a particular action, to a particular command. So you can do while active, when pressed, when released. There's one other one that I can't remember off the top of my head that I hardly ever use. And basically, this is how you define actions on your robot. All of it is defined inside of OI. You don't have to worry about it anywhere else. This is the place that it gets defined. Now, we're going to look at a very simple shooter example. We have our shooter subsystem. Remember that I said you need to either define it as a subsystem or a PID subsystem. We call super, just so that some background setup can happen. We create our front and rear shooter motors because BP had 2 motors on its shooter, one in the front, one in the rear. Using the values from robot map for our PWMs. And then we create a speed controller group just to consolidate everything because the shooter's motors all were set to the same speed when they were used. We created a set speed method that just takes in a speed value from -1 to 1 and sets the shooter speed controller group to that speed. We created a stop motors method which just calls set speed to set everything to 0. And then of course for our default command we create set shooter speed and we specify 0. That way it tells the shooter to stop moving. In set shooter speed, this would be a good command to look at. You can specify a speed to use. That speed is stored. And then in the execute method, that speed is used to set the shooter to a specific speed. This method always returns false because what it expects is when you want to change the speed of the shooter, you interrupt the previous command. Basically what you're doing is saying, okay, until I tell you to stop and do something else, run the shooter at this speed. It could be 0, it could be -1, it could be positive 0.675, whatever you want it to be, so long as it's between -1 and 1. In the event that another command tries to start for the shooter, interrupted will get called, which will just stop the motors. This is generally the only things that we didn't see with the other drivetrain code that we were looking at, a regular subsystem, a command that wasn't drivetrain related, and just a little bit more of an example of how everything looks when you're looking at the operator interface. There is one other thing that we haven't looked at that is an even more complicated thing to understand, and that is command groups, which is literally sequenced groups of commands, chunks of commands that work together to complete a task. And there's 2 of them in this code. One is called auto command group and one is called triple fire. So triple fire looks a bit like this. Now, just to give you an idea of what's going on here, set shooter speed we already went over. It just sets the shooter to a particular speed. Auto kicker, what this does is it turns the kicker until it hits that limit switch that I was talking about earlier, and then it stops. Turns, stops. Turns, stops. Now a command group is like a regular command. It can be started, it can be canceled, it can be interrupted, all that good jazz. With the exception, there are 2 methods that allow you to sort of stick together commands from all kinds of different subsystems so that they work together to complete a task. These 2 methods are called add parallel and add sequential. What add parallel does is it starts a command and then immediately moves on. It doesn't block. Your code continues after a call to add parallel. Add sequential blocks until that command ends. Until that command is finished running, nothing else will run after add sequential. So what you see here is the first thing we do is we say add parallel. And what this does is it starts to spin up the shooter. The next thing we do is we specify add sequential auto kicker 3 times. What this will do is it expects that there's 3 frisbees in our hopper when you run triple fire. And what it will do is the first add sequential will run and kick the first frisbee and stop. Then the next add sequential will run, kick the first frisbee, and then stop. Then the next add sequential will run, kick the frisbee, and then stop. Now there is an error at the end here. This is supposed to be an add parallel. And the reason for that is you want your command to stop in most cases, your command group to stop in most cases when you've run into things you want to run. So add parallel is going to get you to the end here, this end bracket, as opposed to add sequential, which will just sort of sit there and leave the shooter stopped and not let you do anything else until you interrupt the last command, which is not really what you want to do. So add parallel, that's what you want to put there. And basically that's all this does. It spins up the shooter, kicks 3 frisbees, and then stops the shooter, and then ends the command. That's all it does. And that's all you need to do something as complicated as shooting 3 frisbees. There's quite a bit more code that you could have to write in order to make sure that the shooter stays spun up for a long enough time, the auto kicker turns and only turns until it hits the limit switch. All of that is defined somewhere else and is reusable here, so that all you have to do is specify 5 things, and you have a single command that you can call start on or bind to a single button. You push that button, and if you've got 3 frisbees in the hopper, it will go kick, 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 and then stop, and you're good to go. It's fired 3 frisbees, you can go get 3 more and fire again. The auto command group does something similar. In this case, it also defines a name for the command. You can do that by calling super and then handing in a name for the command. In this case, the auto command group, what it does is it runs the kicker and also does a couple of go to set points. The first one goes to 60 inches and has a timeout of 4 seconds. The next one uses the gyro to turn negative 45 degrees and has a timeout of 2.5 seconds. One thing that I didn't mention in the PID example, sometimes it's a good idea to have a timeout on your PID, just because if something goes wrong with your PID, your robot could sit there indefinitely and try to complete the PID actions and never let you control your robot on your own again. That would be kind of problematic. So just want to make sure that that doesn't happen. But one thing that I want to mention here is, you remember how we just talked about triple fire? Like I said, command groups are also commands, so you can use them in add sequential. So the first thing that we do is we run the auto kicker. This is just to make sure that the kicker is in the right position to kick a frisbee. It will turn the kicker until it hits the switch. Once it's hit the switch, it stops. While it's doing that, running in parallel, it does add sequential to drive the robot forward 60 inches. After it drives forward 60 inches, or the 4-second timeout gets reached, it will try to turn negative 45 degrees. After that is finished, you add sequential again, and this is one of those cases where you don't want to use add parallel, because that means your command group will end and that would cause problems. In this case, you call add sequential and you create a new triple fire, which will fire 3 frisbees all by itself without you having to repeat all of that code. Once the 3 frisbees are fired and the shooter is spun down, the auto group stops. And that's basically all that it takes in this instance to create a relatively complicated autonomous program, because you've defined everything that you need in order to make it somewhere else, and you just reuse the pieces as you need them. As I mentioned in the previous video, if you watched it, this is a very quick rundown, and obviously I didn't go over everything. Like, we didn't even look at AutoKicker to see how it actually works. We didn't look at any of the drivetrain stuff, even though it's relatively similar to what we had before. It does include a gyroscope, which does change it some. There is a lot more here that you could digest if you wanted to. Command-based is really cool because it makes so much of your code reusable that you can create some really complicated stuff without really doing all that much work. Normally, for something like this, you would be recreating the wheel a lot. You would be rewriting a lot of pieces of different code, just tweaking them slightly in order to make it work. But with commands, you don't have to do that. You can create a command that takes in the tweak information, and then using that command, just apply the tweak information the different ways that you need it in order to create different actions and different scenarios for the different things that you need to do. That being said, I can understand that this is fairly complicated, and of course this is advanced, and we're not actually taking the proper amount of time to go over this. So if you have any questions, please let me know. Like I said in the last video, gallbladder surgery coming up at the time of recording this video. So send me a message on Facebook, text message, phone call, email message. I almost forgot the fourth thing that I said. Just let me know. I'll get back to you when I can. And I will try to answer your questions. If there's questions about this, like I said in the last video, more than likely I'd want to sit down with you to try to answer your question, to try to be a little bit more clear. It would be very difficult for me to disseminate the information necessary to explain what's going on over text or in a phone call. So if you want to know more, please let me know. I love command-based. I don't know why. There are quite a few teams that really don't like command-based. I love command-based. I think it's very, very cool. And in fact, some of the code for some of my other projects is very, very loosely based on how the back end of command-based works. Specifically the scheduler. So, like I said, if you have any questions, let me know. There will be no more videos after this one for a while. There may come a day where I have some more time, maybe next summer, where I will make some more advanced videos. Specifically, I want to cover more about command-based. I want to cover more about regular Java programming. I want to cover more about grip and vision tracking. If there's other sensors that you guys ask me about during build season, I can cover stuff on those. But right now, there is no plan to do anything other than maybe a video on how to set up Visual Studio Code if I have the time. But that being said, this is it. I can finally stop talking at my computer alone in my uncle's basement and give my voice a rest.